We're doing some more probability. The major lesson today is that for events that are independent, that don't impact each other, then when I do or, it means that you add. And when you see and, it means that you multiply. When we're talking about events and probability, as long as we're not overlapping. Decide whether each of the following statements makes sense or is clearly true or does not make sense or is clearly false. Explain your reasoning. The probability of getting heads and tails when you toss a coin is 0, but the probability of getting heads or tails is 1. And this is true because when you flip a coin, you cannot get both heads and tails at the same time. That is impossible. But the probability of getting heads or tails when you're flipping this, and if it lands on one side, then you have to get one or the other 100% of the time. In other words, the probability of getting heads is 50%. The probability of getting tails is 50%. Or means add, and when you add them, you get 100%. The answer is A. Decide whether each of the following statements makes sense or is clearly true or does not make sense or is clearly false. Explain your reasoning. The probability of drawing an ace or a spade from a deck of cards is the same as probability of drawing the ace of spades. Now, the ace of spades is a card that is an ace and a spade. Drawing an ace or a spade is something completely different. See, the statement does not make sense because there is only one card that is the ace of spades, but there are tons of cards that are either a spade or an ace. Determine whether the following individual events are independent or dependent. Then find the probability of the combined event. The next 4 births at the hospital all being boys. So whether you have a boy now does not impact whether you have another boy, right? So births are independent of each other, right? Whether you have a boy now doesn't impact whether you're having a girl or a boy later. So these are all independent events. And so if they're independent, you're talking about having all boys. So we mean having a boy and another boy and another boy and another boy. The probability of having a boy is 1/2, and another 1/2, and another 1/2, and another 1/2. And what we're learning today is that when we have and, you're going to multiply these numbers. The probability of having a boy and another boy and another boy and another boy is 1/2 times 1/2 times 1/2 times 1/2. That is 1/16. These events are independent, and the probability that that happens is 1/16. Determine whether the following events are independent or dependent, then find the probability of the combined event. Rolling 2 2s followed by 1 5 on 3 tosses of a fair die. A fair die has 6 sides. When you roll when you roll the die once, it doesn't impact what happens when you roll it again. So these events are definitely independent. And now you're going to roll it 3 times, it looks like. 1, 2, 3. You're going to roll a 2. That's 1 out of 6 times that you can get a 2. And then you're going to stop, roll another one, get another 2. That happens 1 out of 6 times. And then you're going to roll a 5. There's only one way to do that out of 6 times. The probability of rolling a 2 and another 2 and a 5 is 1/6 times 1/6 times 1/6. That's 1/216. You just multiply the 6's. Determine whether the following individual events are independent or dependent, and find the probability of the combined event. Drawing 3 queens in a row from a standard deck of cards when the drawn card is not returned to the deck each time. So now there are only 4 queens. And so if I take one out, when I go to pick one again, the probability of getting a queen has gone down because I've taken it out, and it looks like that I'm not going to return it back. So I'm going to take 3 queens out, right, one at a time. The first time, there are 52 cards. So I need queen, queen, queen. The first time, there are 52 cards, and there are 4 queens. The second time, I've taken a queen out. That leaves 3 queens, and there are only 51 cards. And then the next time, I've got only 2 queens left, and there are 50 cards. And I think we're going to go ahead and see what that is. So let's do this calculation for, let's see if we can get the calculator out. So we've got 4 over 52 times 3 over 51 times 2 over 50 is, when you put this in the calculator, it's 1 over 5,525. These events are dependent on each other because removing a queen now and not putting it back impacts the probability of getting a queen later. Determine whether the following events are independent or dependent, then find the probability of the combined event. Randomly drawing and immediately eating 2 red pieces of candy in a row from a bag that contains 5 pieces of candy out of 48 pieces of candy. Now let's see here. So it looks like you're going to randomly draw and immediately eating 2 red pieces of candy in a row from a bag that has 5 red pieces of candy out of 48 pieces of candy total. So if you're eating these red pieces, then you're impacting the probability of getting drawing red pieces in the future. So these events definitely look dependent. And let's see if we can calculate this probability. So then we're talking about the first time. So you're going to eat 2 pieces and you want red and then red again. Well, the first time there were 5 red pieces out of 48. And then the second time it was, we have 4 choices out of 47. Let's take a look at that. It says round to 3 decimal places. So 5 out of 48, or I guess we can use this now if it doesn't want it as a fraction. Let's do it. So 5 divided by 48 equals that, times 4 divided by 47 equals that. And it says round to 3 decimal places, 0.00, and this 8 moves up to a 9. 0.009. I'm sorry, it goes here. 0.009. Dependent. Determine whether the following individual events are overlapping or non-overlapping, then find the probability of a combined event. When the events are overlapping, that means that some things can happen in both events, that the events share some commonalities. Non-overlapping means that the events could not possibly happen at the same time. Getting a sum of either 2, 9, or 10. Well, you can't get both a 2 and a 9 at the same time. You can't get both a 9 and a 10 at the same time. So these are definitely non-overlapping. And so because they don't overlap, if you want to know the probability of getting a 2, a 9, or a 10 on a roll of 2 dice, then you need to find the probability of a 2 then add it to the probability of a 9, and then add that to the probability of a 10, because or for non-overlapping events means that you add. All right, so we know from last assignment that this is out of 36, right? So you have 6 choices for the first die, 6 choices for the second die. So the total number of choices you have is 36, and now we just need to count the ways of getting each one of these. There's only one way to get a 2, so that's 1. And then how many ways can you get a 9? You can get a 9 by doing a 3 and a 6, a 6 and a 3, a 4 and a 5, and a 5 and a 4. And then you can get a 10 by doing a 4 and a 6, a 5 and a 5, and a 6 and a 4. So this is 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 36 reduces. 8 out of 36. 4 goes into both of those, is 2 over 9. Determine whether the following events, individual events, are overlapping or non-overlapping, then find the probability of the combined event. Drawing either a red 5 or a red king on one draw from a regular deck of cards. Well, you can only get a red 5 or a red king. You can't draw both of those things. So they don't overlap. You can only do one or the other. And so the probability of a red 5 is 1. Oh wait, there are 2 red 5s, so it's 2 out of 52. So there's a 5 of diamonds and a 5 of hearts. And similarly, there is a king of hearts and a king of diamonds. So that is 2 out of 52. And again, because it's or and they don't overlap, you just add these together. It's 5 out of 52. And this reduces to 1 out of 13. These events are non-overlapping, and the probability of getting one or the other is the sum of the probabilities. It's 4 over 52, 1 over 13, simplified. Determine whether the following events are overlapping or non-overlapping, then find the probability of the combined event. Drawing either a non-face card or a queen. A non-face card, did tons of non-face cards, right? Or a queen. So the non-face card, that's ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or a queen, right? So we're leaving out the jack and the king. So that is going to be, and then you multiply each one of these by 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 11 cards, they each have 4 suits, so it's 44 out of 52. This reduces to 11 out of 13. A non-face card and queens do not overlap. There are no queens that are non-face cards. Use the method of your choice to determine the following probability. Drawing 3 5s in a row from a standard deck of cards when the drawn card is not returned to the deck. So we did this already, so I need to draw a 5, and another 5. I believe earlier they were queens, but the idea is the same. They're 4 out of 52, 3 out of 51, 2 out of 50. We did this exercise earlier. Let's see if we can go find it. It's 1 out of 55, 25. Use the method of your choice to determine the following probability. Drawing either a 9 or a 6. A 9 and a 6 don't overlap. There are 4 9s plus 4 6s all over 52. 8 out of 52 reduces, divided by 4, 2 out of 13. Use the method of your choice to determine the following probability. Looks like we're asking the same question again, drawing 3 6s in a row. It's 1 out of 55, 25, as long as you're not returning it back to the deck. Use the method of your choice to determine the probability below. Randomly meeting either a man or a Republican in a group of 60 Democratic men, 50 Republican men, 20 Democratic women, and 30 Republican women. So now we definitely have some overlap because men and Republican overlap because there are some Republican men, right? So when you're doing OR and there's overlap, then you need to take all the stuff in A, add it to all the stuff in B, and when you do that, you will overlap, and then you need to subtract the amount that's in both A and B. We'll see right now how that works out. I want men or Republicans, and let's see what happens when we just do this. Well, let's look at all the men. So here's 60 men here, happen to be Democrats. I got 50 men here who are Republicans. Okay, so who are the Republicans? Well, I got another 50 Republican here, right? And I got another 30 Republicans there. Right. So here are all the men. Here are all the Republicans, right? And so you can see that I have easily double counted these people, right? So I can either take one of these 50s out, or I can just go ahead and add everything. So that's 100, and this is 100 plus 90 is 190. And then I have to take out 50. And so now, taking out this 50, that leaves me with 140. How many people do we have here? So we've got 140 out of how many people? So the total number of people is, we got 13. How many total people are there? So there's 60, 50. We have a total of 160 people. 110 men and 50 women. So out of 160, that reduces to 7 out of 8. Determine the following probability. Randomly selecting a 3-child family with either 0 or 3 children. 0 or 3 girl children. So you've got, so this is an OR and there's no overlap. So you need the probability of getting 0 girls or 3 girls. Well, the probability of getting 0 girls, that's one way out of 8. Let's just make sure we see why that is. So boy and boy and boy, 1/2, 1/2, 1/2. That, when you multiply, is 1/8. Three girls, girl, 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 1/2, 1/2, 1/2. That's also 1/8. When you add, that's 2 over 8, which reduces to 1 over 4. A new cold medication was tested by giving 100 people the drug and 100 people a placebo. A group consisted of 90 who were given no treatment. Oh, I don't know if I have the table. Let's see if I can get the table here. So I didn't have the, I didn't copy the chart. So we'll just do this in my math lab. So let's look at this table now. We have a table now, and it's improvement, no improvement, total, cold drug, placebo, control, and total. All right, so I want to take this thing here. Let's go ahead and answer this carefully. Put this here. All right, so the first question is, what's the well, let's do this carefully. So what's the probability let's see what it says. What's the probability that a randomly selected person in the study was given the placebo or was in the control group? Given the placebo or in the control group, no overlap, that's 210 out of a total of 320. We'll put that in. Let's see if that works out. 210 out of 320. I think it's going to have us round to 3 decimal places. 0.656. Let me just double check that. 0.656 looks good. Let's put that in. 0.656. See if that works. 0.656. Likes it. What's the probability that a randomly selected person improved? A randomly selected person, let's get the eraser. A randomly selected person improved. Who are the, so the improved is here. This is 135 just out of everybody, right? So 135. So the most important question in probability is that it's just out of everybody. What is it out of? And so just improved out of everybody. 135 out of 320. .422. Let's see if we put that in. 0.422. Looks that. Okay. What's the probability that a randomly selected person was given the drug and improved? Given the drug and improved, which means that you're going to be looking at the intersection of two things. Given the drug, the cold drug, and they improved, that's the intersection of these two. Given the drug and improved, that's 65 out of 320. That's out of everybody. 5 divided by 320. 0.203. See if it makes that. What is the probability that a randomly selected person who improved was given the drug? So then the question is, this is out of all the people who improved, right? So when we make our fraction, this is crucial. Let me copy this one over. So this one is trying to be slick, right? It says, what is the probability that a randomly selected person who improved, right? So this is only asking about the people who improved. Let's see if we can find this. So this one, yeah. Right, so what's the probability that a randomly selected person who improves? So this is out of 135 people. These people were given the drug out of 135 people. It's this fraction that they want. Of course, they want you to put 65 out of 320, but it's out of the people who improved. 65 out of 135. Most important question, the probability is out of how many? 0.481. Let's see what it looks like. What is the probability that a randomly selected person who was given the drug improved? So out of all the people who were given the drug this time, right? So this is out of who was given the drug. 110 people were given the drug, and 65 of those people improved. Out of all the people who were given the drug, what percentage improved? 65 out of 110. .591. That. The probability, let's look at this table. The probability that a randomly selected person who was given the drug, the probability that a randomly selected person who was given a drug improved is blank. The probability that a randomly selected person who was given a placebo improved. Okay, so let's see what's going on. So it looks like, if we look back at this table, that the probability that somebody improved when given the drug was more than if they were given the placebo, which is nothing, or if they weren't given anything, right? So it looks like it's better on both ends, and that this drug actually works, right? So it's greater than, and so it appears that the drug is effective because it's doing better than nothing, and it's also doing better than people who were given nothing at all. Let's see if that works. Great, last question, we'll do it here. You roll 2 dice based on the probabilities shown in the table. What's the probability that you'll get a sum of 3 on the first roll and a sum of 4 in the second roll? There's the word and. It means that we're going to multiply because these events are independent. I need to multiply the probability of getting a 3, which is 2 over 36, and then times the probability of getting a 4, which is 3 over 36. The probability is 2 over 36 times 3 over 36 because the events are independent, so it's not this one. I'm liking A. The probability is 2 over 36 times 3 over 36 because the two events are independent. Hope it helps.